CAPM graph intuition. And why is that important for you as a student studying Introduction to Finance? Well, I feel like we all get the theoretical concepts applied to CAPM and all the different lines like the CAL, the CML, and the SML. But how do we really get to make sense of all its really mathematical core concepts? And why will that help us do super well on our exams? This is exactly what this video is going to try to help you do. I really want to make sure that you're able to understand all the different underlying concepts within CAPM, especially with their graphs. And that's why I call this video CAPM Graph Intuition. We're going to be looking at the intercept, the slope, the fairly valued versus overvalued and undervalued concepts, as well as the efficient frontier. Now, this video is not going to be super exhaustive, but it's going to try to walk you through the different steps that you need to understand. If you need to go through all the different proofs that I've written on this PDF that we're going to go through together, it's in the description below. And feel free to definitely give it a shot, and send me a shout if you need more help with it. I'd be more than happy to do a specific video or at least point you in the right direction. So let's give it a shot. So as you can see on your screen, we have two different sets of proofs, okay? We have the CML and the SML. And why I did that, and you can see that they're very similar, is because in all reality, the CML and the SML, and even honestly the CAL, are almost the same thing, but we're just looking at different considerations. Now, if you can see on the graph, on the screen, you can see that we have different y-axis and different x-axis. But you quickly realize that the SML and the CML have the same y-axis. They both are looking at expected returns. But the CML is looking at expected returns vis-a-vis risk, whereas the SML is looking at expected returns vis-a-vis beta. So that's the first key distinction that you need to make. The CML and also the CAL deals with expected returns as your y-axis and risk as your x-axis, all right? Whereas the SML looks at expected returns on your y-axis, but it looks at beta on your x-axis. That's the first key distinction that you need to be able to make. Now, another thing that I want you guys to be able to realize is that these functions are actually not very intimidating in the way they look, just by looking at our graph. Like, check out the CML and check out this SML. They're just simply lines, all right? They're simply lines, and lines are really, really good for us because that means that they're easy to understand through a mathematical lens. Now, I'm sure you remember y equals mx plus b. That's the format for any given linear function. It's a very simple format in which, as you can see right here, we have, our y, then we have our slope, then we have our x, then we have our b, which is our intercept. Now we know that x is our independent variable, and we know that our y will be dependent on whatever we place as our x, okay? And what's really cool is that when you actually kind of do a deep dive into these concepts, you realize that, hey, these weird formulas that are like k equals rf over the slope right here times the risk of the portfolio seems really, really straightforward. And then when you look at your SML, well, that function also seems really straightforward because we could replace all of these different components with simplified components that deal with a linear function. So we could make our SML and our CML lines super duper similar to our linear lines format that we all know and love, y equals mx plus b. So that's something that you need to be able to understand. And once you understand that, you're going to be able to define all the different words that they could, or like at least understand all the different words and concepts that teachers, profs, exams may throw at you on an exam, assessment, or project. So once we look at this, I want to make it super clear, and we're just going to look at the CML, for example. So we're going to look at this. We know that y equals mx plus b is the format of a linear function, okay? And we know that because we're looking at a linear function, our b is our intercept, okay? Our intercept is the point at which our vertical axis crosses with our line, okay? And to make that, simplified, essentially what we're saying is that we have our line, and we have our vertical axis. Well, we want to know, well, when do they intersect? Okay? When do they intersect? And a really good example of that point of intersection is to know that the point of intersection is a place, especially for your CML, is a place at which you will have no risk, okay? It's a place at which you will have no risk, but you will still have some expected returns because you're not here at the point of origin. You're at a place at which, yeah, sure, your risk is at zero, but you're actually getting some sort of return in this case, some sort of y. And that's why our intercept's actually a plus and sometimes a minus. That's why it's a value, okay? That's why it's a value here. So what we want to know is that actually in finance, and this is super duper important for all of us and actually applies to real life, is that in finance, there's, and just in economics in the world, there's actually investments that we could make that are guaranteed, that actually provide zero risk at all. Like you're 100% sure that you're going to get your money back and some. And in the scope or in the realm of your introduction to finance course, we're going to call that idea the risk-free asset. And the risk-free asset, as the title says, has absolutely no risk, okay? So if you go right here, remember that the risk-free asset is literally risk-free. Therefore, its risk is equal to zero. And well, we know that if something has risk of zero, it has to be on our vertical axis. Therefore, in this case, our risk-free rate would obviously be on our vertical axis because it has zero risk, but it still allows you some sort of returns. So in other words, what I'm trying to say is that our risk-free rate is our intercept. Okay? What I'm trying to say is that our risk-free rate will be our intercept. And this is super dope because it makes it very obvious to us on an exam if they ask you something along the lines of, hey, what is the intercept of your CML? Well, you now know that that's your risk-free rate. Now, really quickly, as I said previously, we know that our CML and our SML are going to be so similar. And you can see that just by taking a really wide glance at my notes, that they're almost the same thing, except for a few little tweaks, okay? Well, in this case, the few little tweaks that I'm making is that because our CML deals with beta as its x-axis, as its horizontal axis, then we would have to deal with something slightly different in respect to our risk-free rate. And that's why I want to discuss this idea. So our intercept of our SML turns out to also be the risk-free rate. But why is that the case? We know that our risk-free rate has zero risk, but it does provide some returns, okay? So why is that? And why in this case will, when we have our risk-free rate, why is that equal to zero? Why is that our intercept of our SML? Why can we say that the risk-free rate has a beta of zero? That's essentially what I'm trying to say in a really bad manner, okay? So what I want you guys to know is that the risk-free rate, because it has risk of zero, will not contribute to the variance of the market. So the variance of the market will not actually be fluctuated or it will not change based on any given risk-free rate. If something has no risk, it cannot contribute to the risk of the market, right? If we look at the S&P 500, for example, or the TSX, the Toronto Index, a bunch of different companies with their own risk and returns, well, we know that if the risk-free rate has zero variance, it could definitely not contribute to beta. And you should definitely look at another video of mine if you want to have a better understanding of what beta is all about. Essentially, beta, we're trying to see, well, to what extent does a security or a position contribute to the variance of the market? And what I mean, to what extent, I mean, to what extent is the variance of a specific position going to contribute to the total variance of the market? It's a really good way and a neat way to understand what beta is all about. So with that being said, because we know that the risk-free rate has no contribution to the market variance, we know for that reason that it must have a beta of zero. And you could run the math if you really want to. You could definitely do the proof and you'll see that that's the case. So for that being said, or with that being said, we now know that, hey, our intercepts for both the CML and also the CAL and the SML has to be the risk-free rate. So that's the really cool thing. Now we get to know, hey man, we know our beta. We know our B, we know our intercept, no matter what. So in all cases, they will have the same intercept. Now, something that I definitely want you guys to quickly understand, although I already did discuss it, the CML and the SML are super duper similar. They're super duper similar, but they have different horizontal axes, okay? They have different horizontal axes, maybe, is that the word? But the idea is that the CML deals with risk and then the SML deals with beta as its X filter. So obviously, if we're looking at a line, our Y, whatever's going to be returned, so in this case our K, okay, whatever's going to be returned will be directly dependent on whatever point we set as our X. So literally any point on our horizontal axis, okay? Any point on our horizontal axis. Therefore, what I want you guys to know is the reason for which, for a CML line, what we have right here is, I like to call these risk P or OP, it's easier to say. But the reason why it's actually OP in this case, no gaming pun, is because that's our x-axis, okay? That's our x-axis. So whatever we place as our OP, okay, whatever we place as our OP will definitely change the K we actually return. And the same idea applies with our beta, right? As being our horizontal axis, when we look at our function, we can definitely know that whatever happens to our K will be directly dependent on whatever beta we place. And that's why we discuss this concept of, the return of the market being equal to K if beta is 1, because in that case, well, it's the same thing. So that's something that I want you guys to be able to understand. And then another really key point for you guys to be able to kind of grasp on the field of what you may see on your exam is that on an exam, they may ask you a bunch of questions on the slope. Like, well, what happens if the slope is steeper or downwards or whatever the case may be? Does that mean that something happens to the market risk premium? Does that mean that something happens to the Sharpe ratio? Does that mean that something happens to the risk-free rate? And you want to be able to understand, well, what is a slope? What is the slope of my CML or my SML? And this kind of PDF file actually does that for you. It gives you a really good step-by-step idea of what's happening. I'm not going to go through it exactly to the T, but I want you guys to be able to remember, if we look at our screen, that the slope of a linear function, remember, we're dealing with linear functions, we're dealing with lines. Therefore, the slope is equal to y2 minus y1 over x2 minus x1. That's so important, and essentially why that's important is because it's going to allow us to see why we have these random looking slopes as the slopes of our lines, especially our CML and our SML. Well, the reason is because, as you can see, you can select any combination of x and y to figure out what's the slope of your line. And typically what what a diligent person would do is they would use the points that we already know, which is the risk-free rate and the risk of the market, as well as the risk-free rate, essentially the returns of the risk-free rate and the returns of the market. So if you know these things, you're able to place them onto our little slope consideration. y2 minus y1 over x2 minus x1. And then if we go through all the different iterations and steps, we quickly see that because the risk-free rate has no risk, therefore that's equal to 0. Therefore, we definitely see why OM, of course, the risk of the market, is actually our denominator. We see that that's simply the case. Like, it makes total sense, right? OM minus 0 remains OM. So that's exactly what the screen shows. So that's the first thing that I want you guys to be able to understand, is that with that, you're able to actually figure out what is my slope. And in this case, you quickly see that your slope is equal to the Sharpe ratio, right? You quickly see that this is the Sharpe ratio. And you just do that by doing a little proof, a little mathematics, if you will. And then the next point that I want you guys to be able to parallel this to is that the same idea applies to the SML. The same idea applies to the SML because on your SML, you also have a line. Therefore, we could also run the classic y2 minus y1 over x2 minus x1 to find the slope. And you're going to be like, well, why do I not have a denominator in this case? Well, you still do, but the idea is that you could actually cancel it out because of basic mathematics. So if you look at, our little proof here, you see that we have ERM minus ER, or just RF, over BM, so beta M, minus the beta of the risk-free rate. But because we know that the beta of the risk-free rate is equal to 0, and because we know that the beta of the market is equal to 1, all that is left for us is ERM minus RF. All that is left for us is ERM minus RF. And for that reason, it becomes painfully obvious that our slope is equal to this. Now, I want to make a little jump to what these slopes actually are and what they mean. So the slope of your CML is what we call the Sharpe ratio. Okay, you got to know it. You got to know that that's the Sharpe ratio, okay? And the Sharpe ratio is really cool because it's, once again, the slope of the CML. It's a measure of portfolio performance for investors and managers and analysts and, all that good shebang. And then you need to know that a way to understand what the Sharpe ratio actually does is to look at it from this perspective. The Sharpe ratio, essentially, it looks at how much additional or excess returns you make for any increment or any given additional level of risk. And I don't think I said that in the right way. But what I'll say is I'll read what was actually available on our screen, and you'll see that it makes total sense. So the Sharpe ratio should actually prompt the following question. The Sharpe ratio should lead you to the following question, which is how much excess return are you generating for every unit of risk taken? So if you know math, if you know like economics, you would see that, okay, for every incremental change in risk, how much excess return am I making? For every unit of risk added, how much returns am I actually making? That's what the Sharpe ratio is all about. And typically, you would want to have a very big Sharpe ratio, such that for every unit of risk that you add, you're making a whole lot of returns. That's essentially what you want, okay? And typically, a smaller Sharpe ratio means that you're not making more risk than another Sharpe ratio, and vice versa, and all that good stuff. And then what we want to look at is, once again, the slope of our SML, which is what we call the market risk premium, okay? The market risk premium essentially is equal to, ERM minus RF. And what you want to know with that is, well, it's the slope of the SML, and you want to be able to understand that we're looking at the following question. How much are investors compensated for the risk they've undertaken? Which is a very similar consideration to that of the CML and the Sharpe ratio. But at the end of the day, you want to know that that's a question that is prompted by that specific consideration. So now you're able to understand what are the key differences and what are the key similarities between the CML and the SML, as well as understanding, well, what is the intercept, what is the slope, and how can I make sense of this on an exam? That's exactly what this video did, and hopefully it helped.